Hi, my name is Sumire Sato, and I'm a postdoc at University of Florida. Today, in this video, I'll be talking about how to get started in R Markdown. I'll preface this by saying this is assuming that you already have R and R Studio installed. So if you don't have that installed, I suggest you to do so, and a lot of the jargon used in this video should be a little bit easier to understand. So again, assuming that you already have some experience in R, um, you are probably able to do different statistical tests. R Markdown allows you to combine different chunks from your R file and combine it with some annotation, export it to a PDF or HTML or other types of document, and share it with other people. This makes sharing results, sharing script with annotations a little bit more easier, especially if you're sharing some R script that to someone who doesn't have too much experience with R. Creating documents with R Markdown starts with this RMD file that contains a combination of Markdown and R code chunks. So this .rmd file is fed to knitr, which executes all of the R chunks and combines a new Markdown document and includes the R code and the output. And then it's processed by Pandoc, which is responsible for creating a finished web page or a PDF or a Word document. And R Markdown makes this extremely simple on RStudio by just pressing this quote unquote knit button that you will see later in the tutorial. So Markdown is a simple formatting language designed to make authoring content again, easier for everyone, including people who are not that familiar with R. So rather than write it in a complex markup code, you write in plain text with formatting cues. The first thing that you should do to get started with R Markdown is to install package R Markdown and install package knitr. And you might have to restart your RStudio. If these options aren't coming up, just try to restart it and update your RStudio. Um, but after you have those R Markdown packages installed, you could open a .rmd file by going to File, New File, and clicking on R Markdown. You could see that there are different types of things that you could do here. You could add headers, you could add simple text, you could type in italics or bold, and you could create lists. And this apostrophes indicate different chunks of code. With our Markdown, when you set your options, you could set the options that you are inserting an R code. You will put a title, and then you could insert R code chunks, and then it will give you the output. So, for example, the following code chunks computes the data summary and renders a plot as a PNG image, and then it attaches it to the file. With R Markdown, you can create many types of output from a single .rmd file. I typically just choose to output my files as an HTML document so that anyone can open it in their browser. They don't have to have Word or Adobe installed to open a PDF. Um, but there are various different types of output that you can choose to output with R Markdown files, and these formats can be specified in the metadata that you set up at the beginning when you are creating your R Markdown file. So to summarize this, I'd like to go over some pros and cons. So the obvious pro is integration with R, and you could have both your script and your output all in the same document. And the person who you are sharing the document doesn't have to have R installed, or they don't even have to have familiarity with R. They could just look at the output. This leads to great reproducibility with data sharing, and you could also customize it with notes. So for example, if you are doing different ANOVA tests and you want to have some personal notes that this ANOVA was significant, but this ANOVA was not, you could add that in there. So if you are sharing this in meetings, it's very easy to have your notes read in front of you. There's also the flexible output styles, and it's relatively easy to use, especially in RStudio. Cons is with the flexibility of the different output styles, there might be a little learning curve at the start, and performance may be slower with huge data sets. There's also the complexity if you choose to use LaTeX or JavaScript, and there might be some compatibility issues with output formats, especially if you decide to use an older version of some programs. So now I'm just going to do a brief overview of getting started in R Markdown. So this is my R Studio, and you could open a new R Markdown file by going into File, New File, and R Markdown. It will prompt you to choose a name for your file, author and date, and your output format. I am just going to press OK. And you have your first R Markdown file right here. This is your metadata that indicates the name and the date, some chunks of R code, and some text. This will output the summary descriptive statistic for the dataset cars and plot pressure. So you can knit it, but you also need to save it first. So I'm just going to name it the same thing, tutorial. And you can see that it's a .rmd file, not a .r file. Just going to press save. And here is your new HTML file. You could also choose to open it in a browser. So this is my Microsoft Edge browser. And you can see that anyone can open this file in their browser. If you want to save it as PDF, you could always do print and then save as PDF. So in this next part, I will talk about some brief things that you could do in the text. I'd encourage you to Google some R Markdown cheat sheets that are on the internet, because these can be very useful to have on your desk or have on your desktop um, for quick references. But again, quick things that you could do with your text. The number of hashtags that you include before your text indicates the size of the header. So I'm just going to put header 1 here, header 2, header 3, header 4, and so forth. You could also indicate the type of font that you want. So you could do 1 star for italics, 2 for bold, and 3 if you want to do bold italics. Sorry. And you could see in the sample text that you could also include hyperlinks. I mean, you could also include links as they are, but you could also include hyperlinks. So with square parentheses, you could say click here. And for example, I'll put my GitHub. And we could knit this again, and you can see the different types of header size as well as the font styles. And when you click, then it gives me my GitHub. So some useful things that you could do in the text. So in the next part of the demo, I will be talking about doing ANOVAs and making figures in R Markdown. And I will be using the data from our already published manuscript titled Resting State Brain Network Segregation is Associated with Walking Speed and Working Memory in Older Adults. This paper was published in 2025 in NeuroImage. So I'd like to give a little background to orient you to the data a little bit better. So we looked at resting state brain network segregation in older adults because in aging, we know that network connectivity is more diffuse or more spread out. And these functional networks measured by resting state fMRI are more diffuse, and this could be a type of age-related neurodifferentiation. And characterizing intrinsic brain connectivity differences in older adults across a wide walking spectrum can provide insight into mechanisms of why there are functional decline in some older adults, but there are resilience in others. So in this study, we looked at group differences. So we had young adults, we had older adults with higher function, and older adults with lower function. And older adults were parsed into these higher and lower function groups from their short physical performance battery score, or SPPB. And then we had all of our participants do an MRI scan of the brain, and we quantified network segregation in different functional networks. Our hypothesis was that younger adults will have higher segregation than older adults with higher physical function, and that older adults with higher physical function will have higher network segregation compared to older adults with lower physical function. In this paper, we also identified associations between network segregation and walking speed. Just to note that this is not covered in the demo, but if you want to read further, you can read our paper. So a little bit of background on resting state functional connectivity. So typically what is done is that a seed region is chosen and identified. And in this case, the posterior cingulate cortex is identified in blue in A. And then the bold time series is extracted from this region. And then you could do a voxel-wise correlation at every voxel related to the seed time series to create a seed correlation map, as you can see in figure C. So these seed-based methods are powerful that can inform us about the large-scale spatial organization of the human brain as a whole, but they don't fully address how connectivity is structured between different functional networks. So in this study, we are using network segregation analysis, which uses different functional networks identified by nodes. And a higher network segregation will mean stronger functional connectivity between brain regions between the same functional network, but weaker connectivity between the different functional networks. So how this network segregation score is calculated is you take the average for all the within network connectivity scores. You subtract the between network connectivity scores for that one specific network, and then you normalize it by the within network connectivity scores. With this, you get an average network segregation score for each separate functional networks. So in this next part of the tutorial, I want to show how to do an ANOVA and how to have some plots in your output file. So here I have my sample R Markdown document, and I have my metadata indicating the title, output style, and the date. And this rsys date indicates that I want the date to change to whenever I ran it. So if I run it today, it'll be today's date, but if I run it again a week later, it'll be the different date. My different R chunks, you could set some settings as this include true or false. If you include false, it means that this R chunk won't go into the output document. And I typically have the setup portion as false just because the people who I share it to don't necessarily need to know or want to know what types of packages that I use. But here I just load my data in and I have some notes here, but I have some factor variables. So there is a group variable that indicates which group my subjects or participants were in. So young adults, older adults with higher physical function, or older adults with lower physical function. And then I have my sex variable, male and female. And I just want to make sure that these are coded as factor variables. I have that there. In case that you want to run a chunk without knitting your R Markdown file and just want to look at the output, you could just click on Run Current Chunk right here. And you see that here I didn't do too much. I have my data loaded, so we could go in to look at the data. I have my subject IDs, and again, for this data set, I have a network segregation score and one for each functional network. Just going to close that. So my next section is running the ANOVA. Here I'm only going to do one ANOVA, but I try to streamline it as best as possible so it will be easy to make a for loop if I wanted to, or run the same ANOVA with different variables. So here I am looking at the group differences between the group differences in the right vestibular functional network. So my variable is called the right OP2, and I just have print this variable just so that in my R output file it'll also say right vestibular in addition to that header. And then here I just select the data that I'm going to use and I print my summary statistics for each group. I want to do this to double make sure that the averages and the standard deviations are what I expected, and then you could check that with your figures as well. And then in the next section, I fit my ANCOVA novel model, looking for group differences, but accounting for covariate sex. And then I look at simple main group effect, adjusting for multiple comparisons with the home Bonferroni method. And then again here, I could run this. And you can see that it gave me my summary table with my means, standard deviations, and the number of participants that went into the analysis. And I could see my ANOVA results. This was significant between groups, and I could see that my young adults had a higher network segregation compared to my older adults with higher physical function, which was group 2. And my younger adults also had higher network segregation compared to the older adults with lower physical function, but the two older adult groups were not significantly different. In the next section, I want to plot rain cloud plots. So this combines the individual data as scatter plots and then a box plot for each group, and then has a distribution curve. I do this with the ggplot package and the ggrain package. And again, I could run this and it'll have my rain cloud plot. So you can knit this and get this all in one document. So I am just going to try and knit this. And you can see that it even gives you the warnings as well. But it gives me my ANOVA table and my post-hoc analysis and my figure. Sometimes running chunk by chunk is also great because when you look at the output, you could have your notes. So here, I could always have notes to say um, significant differences between groups, young adults greater than older adults with higher physical function, young adults greater than older adults with lower physical function, for older adult groups, HF, and low function, or not um, significantly different. And then when I knit this again, it'll include your notes. So when you are going over this with your collaborators, it might be a little bit easier to digest or go over the results a little bit faster. So that's it for the tutorial that I have for this content. I hope you enjoyed it, and this code for the ANOVA and rain cloud plots will be on my GitHub. Thank you for listening.